around the fireplace. No, not really. Um, a colleague of mine, Edward, another colleague, Christian, and Eduardo Scarpellini from the other side of the world, South America, and Edward, Christian, and I built VSF, and Eduardo Scarpellini built Varnish Firewall, which is now joined together into the Varnish Security Cloud. So, I'm going to motivate what I'm going to talk to you about, and first off, you have no idea what this is, and I would like to ask you, how many of you have heard of Varnish? Quite a bit. How many of you are developers? How many of you are operations people? How many of you are management? All right. Cool. I'm going to try to make this talk a little bit for everybody. But to motivate it, I'm going to tell you about the OWASP top 10 security problems. How many of you guys know what OWASP is? Okay, quite a lot. Excellent. So how many of you have seen the top 10? Okay, so less than everybody knows what OWASP is. Cool. Very quickly, the OWASP top 10 is a list of all the most common security problems today. The most common being the most exploited. So the number one is injection. So SQL injection, JavaScript injection, code injection. So that will make your site vulnerable, or make your site exploited. Broken authentication, so people steal your cookies, for example, and make it through your authentication measures to get at your data. Cross-site scripting, which is basically reverse injection because it injects data into your client. Direct object references, which means, oops, your programmer let, or not your programmer, that's not Lin, programmer, oops, some programming object was leaked into the browser. There's a misconfiguration, maybe. Maybe you need defense in depth because the default is not really good enough, and sometimes things get stuck on there by default. There is some sensitive data exposure, which is quite a common one. You leak user data, that's really bad. There's missing access checks, which basically means you have access checks in your tests, but you forgot to put them in when on your backend. There's cross-site request forgery, which is less common nowadays than it was, but oops, your client didn't mean to send that request to you. There was some attacker that injected it. There is a component with known vulnerabilities that you put into production. And does this sound familiar to you? Yeah, some people are nodding in there. And also unvalidated redirects, so it means we forward the user to somewhere, but we didn't validate where we're going. And that's pretty much what we do all day when we have a website. I was at a client once and we did a little small graph of what kind of status codes they were putting out. It was a big media house, and I looked at their status codes, and it turned out that 200 OK was not the most common one. And error code wasn't the most common one either. The most common one was actually a redirect. So, what I'm going to talk about is attacks the attackers in a way, but it's a big wall to scale. Thank you. This is what I've been needing all morning. Other question. But first of all, let's talk a little bit about how the Varnish firewall came to be. So way back when. The reason why we looked at this project was because Varnish has a pretty sweet architecture. I'm not going to go into it, but it's pretty nice. And if you know Varnish, you might know that one of the biggest reasons for it is because it's got a really nice architecture, and it's lean, and it's fast. I could paste in any number of different graphs for people saying Varnish is fast, but right now I don't have any internet, so I didn't put it anywhere. Varnish has super flexible control, so it has a really nice rule set, or it doesn't have a rule set, it has a language, and that language is simple and domain specific, request oriented, and gives you control over your front end, over everything your client is doing. It has real-time metrics. Like, you can actually tell what's going on right now, not later when your analytics kicks in or when you parse your logs, but right now. And something that is not that well publicized, but it has some security barriers. Okay, I'm going to step back a little bit because I forgot. For those of you who haven't heard of Varnish, it's a reverse proxy. So at its simplest, it is just something that takes an HTTP request from your clients, a web request, and sends it to your backends. So, your application server or your JBoss or whatever. But it has some security barriers, and those security barriers do so that all the handlers that take all the input from the dirty, smelly, dangerous internet, and they handle them very carefully so that your machine running Varnish doesn't get owned. We thought that was pretty cool, and so after a couple of years of using Varnish, we thought this is pretty much the Swiss Army katana of HTTP traffic, of web, and we figured that, let's use this for something. A little quote for you guys. I fear not the man who has practiced 10,000 kicks once. I fear the man who has practiced one kick 10,000 times. That's Bruce Lee. So Varnish has really simple hackable rules. It can block web scanners, and it doesn't give you any performance penalty no matter how many rules you make. So we thought that was really cool for making security set out of it. And okay, so it's not a silver bullet, just like the guy with the firewall said. Firewalls are not the silver bullet. But usually we use Varnish to scale a website, so you have some sort of CMS or whatever, and it doesn't perform that well with 100 or 1,000 requests per second. And we also use it to hack around application issues. So, we have a lot of applications, we need to integrate them over the web, or this application doesn't really cache as well, so we hack around with this control language. Unbelievable. And what happened to us at Linpro was that one of our clients was DDoSed, and we solved it with Varnish. First of all, Varnish is really good at handling a lot of traffic, but secondly, at this point, we were basically saturated. The bandwidth was saturated, which means you can really not do a lot of stuff. What was going on was actually they had a whole bunch of scripted Internet Explorers that were repeatedly requesting. And you can look this up, because this was Arab News a couple of years ago, and they allowed us to use the name. The publication was constantly refreshed by millions of Internet Explorer zombies. And the way we solved that was actually to tell those Internet Explorer zombies to go cache. So this is a little piece of VCL, and it says if some header shows that this is the pattern, okay, I'm not going to reveal the pattern here, but because it's different for every DDoS, it wouldn't matter. But if we're matching some pattern that will tell us this is an automated attack, then set the cache control to some really, really stupidly large value, and those clients stopped requesting because they were that stupid. Anyway, this is only an illustration of the kind of flexibility we can do in Varnish, because really the next attack is not going to be that easy to fix, but it will take some thought and then some control over HTTP requests. So that solved it, and we went to the bar box. So your app stack in your business probably looks something like this. Actually, it probably looks more virtual nowadays, but it's probably some Tomcat or Apache, and it's got Nginx Varnish in front of it, some hardware load balancer, and SSL termination. You might have some parts of this or not. You have an application server. You have a database behind it. In context of other firewalls, or web application firewalls, I would like to mention that there is such a thing that's called mod security. It works for Apache and Nginx, and it is a pretty complex beast. It's very good at what it does, which is it has a big rule set. There's a commercial rule set that you can get, and well, it might be a little bit overkill in certain cases. It needs quite a bit of monitoring, support, integration, and you need to squeeze that into your stack somewhere. So it's really good for stopping quite a bunch of those attacks we talked about, but it wouldn't stop the DDoS. You wouldn't be able to make up a rule on the spot to stop the DDoS. Oh, sorry. Yes. There is also Naxi, which is a really nice web application firewall. It's got some of the same principles that we applied in the Varnish application firewall. It's got a small core rules. It does offer some auto learning, but it's also not complete. So it's for Nginx. It's quite nice. I've been looking at other WAFs that I've looked at, commercial ones, are not that interesting because either they're way too expensive, or they're not flexible enough, or they're a combination of those two. So what I really want is something that will let you see attacks in real time and handle them easily, at least your text. So it's a rainy day. Instead of a big custom rule set, then you write your own rules in Varnish, where your ops can get at, where your ops can see those rules, and without hurting feelings. Sometimes you step on toes if you go in and fix an application problem, that you don't actually have authority to. And without breaking things, because the stuff is running in production, and you want to be able to really quickly roll back if you're losing requests. And that's going to put you somewhere around there. That's just an InfiniBand stack. I have a picture of sometimes. So our rules in Varnish Security Firewall. Our rules are a very small rule set. They're custom, and you can build custom rules for apps. We build rules for 1 or 2 apps. And then we put this in production, and the customer is still up, running terrible code. And this type of setups lets us hack quick hot fixes into the stack. So a little bit of the details. The approach was that we built a framework. We put some expert rules for GET handling, for GET requests, basically looking for attack patterns, SQL injection and stuff like that. And then we did a bit of a own module to look at post requests, because you have to look at the post data as well. How did this stop attacks? Well, we stopped some common malicious accesses, SQL injections, contract scripting, and we implemented a cloaking module, which is I'll tell you a little bit about later. Actually, I'll tell you about right now. So cloaking was interesting to me because I thought, what if I want to hide what kind of web stack I'm running from all my users and attackers? I get this frequently actually. I have clients who are saying like, no, we don't want to show any headers for running Apache or Tomcat or whatever. We don't want to show anybody what we're doing. We just want you to see the site. I was like, that's interesting. Let's see if we can do better because actually it's pretty easy to figure out what you're running even though you're deleting the headers. So we did that, and then I also thought, what if I want to hide what the client is running and what it looks like from the web server? So made a module for that, for anonymization of the requests. There's an example. I'm running Delta 9. So there's also cloud security. Yeah, we hate the word cloud, but we can easily deploy the Varnish security firewall on the cloud because it's a small rule set and because it's on Varnish and it's a lightweight program. It goes in pretty much anywhere. That will let you push that web application firewall closer to the user, which is basically what cloud security is all about, because you don't have this perimeter, you don't have one network. So what you want is to push those access controls as close to the user as possible, to your client as possible. So back to mod security and our VCL to show you the difference of these approaches, of the approach we took to the approach that mod security took. This is a mod security rule. It might be one of the more scary, but certainly not more complex than a lot of the others. And I find this kind of bad. Because, well, why? Because it's not parsable. There's no structure in it. Like, sure, it basically says look at the request cookies, etc., and look for malicious stuff, and then it's cross-site scripting, but it's hard to read. Now, the Varnish firewall, the master's thesis for advanced scripting, improved that to make a structured rule, like if, but it's still kind of unreadable now. And the reason for that is because of UTF encoding. Or actually this is just URL encoding. There's a whole bunch of ways of encoding the same characters, and that will actually be really difficult to write, right? These things make it completely unreadable to write these rules, and these are the short examples. That's old school. What we really want is the Varnish firewall, which has rules that look like this. There's a URL, you look for some common SQL statements, and you say, oh, that's SQL injection. The rule ID gets assigned, and we call our severity 1 handler. So that wins. The security handlers or the severity handlers are basically just responses to your, what do you want to do now that you know that there's a problem? Well, you can reject or block, you can send an alert, you can redirect to, for example, a honeypot, so that you're sending the malicious data, malicious traffic to somewhere where you can learn more about it, where you can trick the attacker into thinking that they're actually connected. You can G-line them, which says basically, okay, we have one application server that has discovered that there is an attacker. Let's just block that attacker from everybody, like from our whole infrastructure. So that's the type of stuff we can do. That makes it pretty sweet. There's, of course, a couple of weaknesses with these approaches. How am I doing for time, anyway?
You're good.
How good? Am I going real fast and you guys have a lot of time for questions?
There's time for questions as
Good.
well.
So, the web application firewall, any web application firewall actually, has some problems with it. One of the biggest problems is that it's really easy to spray. So I can construct a script, and that script will be able to fill your logs with alerts. And if I fill your logs with alerts, you're gonna not be able to tell my attacks from just random noise. There's also a trick where you can fingerprint both web application stacks and firewalls. So what I can do is I can say, oh, you are running mod security firewall on Apache. And behind that you have a Tomcat. And behind that again you have some JBoss stuff. It's certainly possible. Actually, another colleague of mine, Eddie Hingebuls, made a script that is called, it has a very strange name. It has an ability to detect, by looking at behavior, what kind of web server you're running, or what servers, because it actually detects 3 layers and backwards. So you can do fingerprinting of your web application firewall and see what are you running, and then target your attacks to evade those application firewalls. One of the reasons why those rules look so nasty as they do is because of URL or UTF encoding, where you can represent the same character in a lot of different ways, and so your rules got to be really complex to take account for that. So those are really dramatic clouds on the horizon. So I have another quote for you. All fixed set patterns are incapable of adaptability or pliability. The truth is outside of all fixed patterns. And that is also loosely. There's of course a lot of work to be done in this open source software that Varnish Security Firewall is. It's basically run as a volunteer project at this moment. And what we're working on right now is a Varnish 4 port. Later on, I mean, one of the top priorities is the Unicode normalization, because actually that is quite tricky. I'll tell you a little bit about fuzzing, because that's important in any security tool. We're wishing for a better GUI. I'll tell you what kind of GUI we have. We have, of course, always a need for updating the rules. I'll tell you about policy D and, of course, packaging. So that's in the future. First off, that's lots of time. So first of all, Varnish 4 released this year, a couple of months ago. It's actually production ready now. I'm running it at some seriously big traffic clients, and they're having good times. And one of the coolest things about Varnish 4, besides streaming and a bunch of stuff, is that it has some really good vmod support. So vmods are ways of making your own code run inside Varnish. You could always do this with inline C, which, yes, is about as scary as it sounds like. It's always been possible, but with vmods you can package these things into nice code objects which you can call in the VCL, in the control language. That's been around since Varnish 3, and it's really cool. But since Varnish 3, there's no binary interface, and therefore you would have to recompile these vmods every time you upgraded Varnish, and they were not packaged. You can see that's a bit of a problem if you're running your site and you want stability, you want repos, you want packaged software, you don't want this sort of hand-compiled hacky stuff. So what happened in Varnish 4 is that there is an actual binary interface so that you can ship vmods and run them on with packaging. And that's really cool. They also have access to a bunch of stuff in Varnish that hasn't been accessible before. Yeah, there's some VCL tweaks that we need to do to support Varnish 4, and the release of Varnish 4 port of the Varnish security firewall is imminent. The second thing is Unicode normalization, which we've been doing some headway with that, but it's a careful job because you want to capture all the possibilities. There's some libraries that we plan on using, UTF-proc, among other things. Fuzzing. So what is fuzzing? Fuzzing is throwing a whole bunch of random data, or not random, semi-random data at an application to see if it crashes, to see what kind of vulnerabilities there are. And this year, El Losa did a level of fuzzing for Varnish, and of course there's never enough fuzzing, but the results were quite uplifting. There wasn't that many crashes discovered, actually none. Of course, he has a whole data center of fuzzers to run on Varnish, so it goes pretty quickly. Secondly, we would like to have a better GUI so that we can manage the rules, the Varnish security firewall rules. We want to view the log in a nice way, and we don't want it to be in PHP. I mean, there's nothing against PHP, but as a security guy, you will have a healthy skepticism to all things PHP. And today, we actually do have a PHP GUI, which is something we inherited from the Varnish firewall, the FW. So, yeah, there is some room for improvement. We would like to expand the rule set, maybe even borrow from, because ever since we started this project, we've been borrowing rule sets from other projects. There's some handwritten rules by Edward, and I wrote a Perl module that translates mod security rules, and that thing still works, so I'll port that to Varnish 4 rules. We would like to take the few things that we don't have from Naxi, because they're kind of nice too. I mean, security changes every day, so. There's also policy D, which is a new thing in a new vmod in Varnish. Basically, the concept is that you write a policy server, and Varnish just talks to it over a known protocol. It's a old technique that is used in, or an old concept used in the mail world or the spam world, where you check with a policy server whether this piece of mail is supposed to be forwarded or not. And it actually makes a lot of sense, because especially for post requests, where you have a huge application stack and this post request may or may not be sketchy. So as an open source project, I'm here to tell you that I would love to get more contributions from people. So there's a whole bunch of stuff, really interesting stuff to pick up on if you would like to play with it. And I think even though I have 3 minutes left, I'm going to ask you guys if you have any questions. Thank you.
Frågorna kan gott vara på svenska också. For you guys out there, you can check out the GitHub page, commotion/DSF, right now, really, if you want.
Hur funkar det? Är det en modul till Nginx eller är det kod eller Perl eller själva reverse proxy-delen?
Reverse proxy-delen är en egen server.
Okay.
Varnish.
So you say it's not Nginx based?
No.
Standalone, Varnish is standalone.
What is the biggest reason? What's the biggest challenge to get this running in a big organization? What do you need to do?
In a big organization, the biggest challenge would probably be compiling all the vmods in Varnish 3. So in Varnish 4, once we finish that port, we will be able to package it, and so you should be able to apt-get install VSF. So that would be the first challenge to deploying this. Second challenge, because there is really only two, would be in tuning the rules to fit your environment. Because you're running an application that is custom written, or even if it's not custom written, it's one of the 10,000 or 10 bajillion HTTP applications out there. And the best type of security is afforded by having a custom rule set. Now, you don't really need to write a custom rule set, but you do need to turn off those rules that are going to trigger false positives. We have a mode in the security firewall for that, where you turn on non-enforcing mode, and then you look at the logs and see, oh, these alerts are kind of bogus, so you turn off those rules.
Okay, sounds good. So we're looking forward to a bright future with Varnish.
Right on.
Good, excellent.
Yeah.
Thank you.
Great.